Chapter 5, Lesson 3, Properties of Operations. Real world link. Driving. Miss Ricardo drives up and down her street to complete different errands. Some of the places on her street are shown below. The number of blocks between the places are also shown. So we have our house, the library, games galore, and the football field. So starting with number 1, suppose Miss Ricardo drives from home to the game, store, and back. Write an expression for each distance. So from home to the game store. Well, from home to the game store, we know that it's going to be 2 blocks plus 1 block because it is 2 blocks to the library and an additional block to the game store. Then from the game store to home, it's going to be 1 block plus an additional 2 blocks. So circle the property that is illustrated in exercise 1, commutative or associative. So it's going to be commutative because that means that you can add in whichever order you would prefer. Number 3, on Monday, Miss Ricardo drives from home, stops at the library, and then drives to the football field. On Tuesday, she drives from home, stops at the game store, and then drives to the football field. Write an expression for each distance. So on Monday, she drives from home and stops at the library. So that's going to be 2 blocks. Plus drives to the football field. Well, in order to get to the football field, it's going to be 1 block plus 3 blocks. Now I'm putting this part into parentheses because it is showing that to get from the library to the football field, it's not just 1 block or just 3 blocks. It's 1 plus 3 blocks. On Tuesday, she drives from home and stops at the game store. So that is going to be 2 plus 1 because it's 2 blocks to the library plus an additional block to the game store. And then drives to the football field. So from the game store to the football field, that's 3. So the property that's illustrated in exercise number 3 is going to be associative. So both Monday and Tuesday have the same numbers that are added. However, Monday has the parentheses around the 1 and 3, while Tuesday has it around 2 and 1. So properties of operations. We have the commutative property. That states that the order in which numbers are added or multiplied does not change the sum or product. So to show that, symbols, we have A plus B is the same thing as B plus A. Or 6 plus 1 equals 1 plus 6. Multiplication, A times B is the same thing as doing B times A. So example, 7 times 3 is the same thing as 3 times 7. Next, we have the associative property. That states that the way in which numbers are grouped when they are added or multiplied does not change the sum or product. So if we have A plus the quantity B plus C, that's the same thing as saying the quantity A plus B plus C. So example, 2 plus the quantity 3 plus 8 is the same thing as the quantity 2 plus 3 plus 8. To show you, that becomes 2 plus 11, which becomes 13. 2 plus, let me go back. 2 plus 3 is 5, plus 8. 5 plus 8 is 13. So order doesn't matter. For multiplication, A times the quantity B plus C is the same thing as the quantity A plus B. I apologize. Starting over. A times the quantity B times C is the same thing as the quantity A times B times C. So that's the same thing as saying 3 times the quantity 4 plus 5 equals the quantity 3 times 4 times 5. So 3 times 20 gives you 60. 12 times 5 gives you 60. A property is a statement that is true for any number. The following properties are also true for any numbers. You have the additive identity. That's when 0 is added to any number. The sum is just going to be that number. So we have the examples. 9 plus 0 is just going to equal 9. 0 plus 9 is just going to equal 9. Multiplicative identity is when any number is multiplied by 1, such as 5 times 1 equals 5, and 1 times 5 equals 5. So the multiplicative identity just means that you're multiplying by 1, and that will just equal that number. Multiplicative, another way to think about it is to multiply. So the multiplicative property of 0 says when any number is multiplied by 0, the product is 0, meaning 8 times 0 equals 0. 0 times 8 equals 0. Any number that you multiply by 0 is going to equal 0. So for example, we're going to name the property shown by the statement. So rewriting down what they have, 2 times the quantity 5 times n equals the quantity 2 times 5 times n. So this one is going to be the associative property. And I can go back and I can look and I see that it matches up with this right here, where we're just changing where the parentheses are. We're not changing any order, we're just changing the parentheses. So this is the associative. Oh, and I do stand corrected. I'm so sorry. It is the associative property of multiplication because you were multiplying, not adding. So the associative property of multiplication. And again, it's multiplication because you were multiplying. So let's check these to see if you understand. Letter A, 42 plus x plus y equals 42 plus y plus x. Well, the only difference from the left side to the right side is we have switched the x and the y. So if I go back up and I look at my different properties, the one in which the numbers can be switched in their orders when it comes to adding is the commutative property of multiplication. Because we had a plus b and switched the order to b plus a. So this is the commutative property of addition. You do want to add in that it's addition because it is adding and you're not multiplying. Letter B, 3x plus 0 equals 3x. Well, for this one, this is going to be the identity property. I'm sorry, the additive excuse me, the additive identity property. Because we are taking our number and we are adding 0 to it. So the additive identity property of, yeah, sorry, the additive identity property. It will benefit you if you practice also saying these different these different properties out loud. So you may wonder if any of the properties apply to subtraction or division. If you can find a counterexample, which is an example that shows a conjecture is false, the property does not apply. So all that means is if you can prove that it doesn't work for subtraction or division, that's called a counterexample. So let's try that with example number 2. State whether the following conjecture is true or false. If false, provide a counterexample. So, division of whole numbers is commutative, meaning it doesn't matter what order you divide it in. Well, we can show that that's not true. If we were to take, let's say, 27 and divide it by 9, that answer equals 3. Now, the commutative property of division would mean that 9 divided by 27 would give the same answer, but it doesn't. It gives the answer of a 1/3. So 3 does not equal 1/3. That is a counterexample. They also had the counterexample of 15 divided by 3 equals 3 divided by 15. And you know what? Let me go back and rewrite the way that I wrote mine, just so it matches up. So 27 divided by 9, does that equal 9 divided by 27? Does 3 equal 1/3? No. No, it doesn't. So this is not commutative. Ooh, not commutative. So let's try letter C. See if we understand this. The difference of two different whole numbers is always less than both of two numbers. The difference of two different whole numbers is always less than both of the two numbers. Mm, Let's try two numbers. Let's go with 8 and then subtract 2. Well, if this is true, then that means that my answer is going to have to be less than 2. And the reason for that, our two whole numbers are 8 and 2, and the answer will have to be less than the smallest number, which is 2. Well, 8 minus 2 is 6. So that is false. Number 3. Alana wants to buy a sweater that costs $38, sunglasses that cost $14, a pair of jeans that cost $22, and a t-shirt that costs $16. Use mental math to find the total cost before tax. Well, we got 38, 14, 22, and 16. Well, using some mental math, I'm going to rearrange this order. And I'm going to take 38 and I'm going to add 22 to it. Then I'm going to add 14 and 16. Now, the reason why I'm adding the numbers the way that I am, 8 and 2 gives me a 0 or a 10. And then 3 plus 2 is 6. 3 plus 2 is 5 plus 1 is 6. So that gives me 60. Plus 14 and 16 add up to 30. 60 plus 30 gives me 90. So adding them in a different order allowed for addition to happen easier. So it's going to be a total of $90. So let's use our same kind of idea for letter D. We have Lance that made 4 phone calls from his cell phone today. The calls lasted 4 and 7/10, 9 and 4/10, 2 and 3/10, and 10 and 6/10 minutes. So I want to rearrange this and put terms together that would make adding easier. Well, I have 7/10 and I have 3/10. So if I take 4.7 plus 2.3, that's going to give me a 0 in my decimal. Sorry, in my in, in my tenths place. And then 4 plus 2 is 6 plus another 1 is 7. So that's 7.0. Now I'm going to add 9 and 4/10 plus 10 and 6/10. Well, 6 and 4 gives me a 10, so I carry the 1. 10 plus 9 plus 1 is 20. So that gives me a total of 27 minutes. So let's look at example 4. We're going to simplify each expression and justify each step. Let me highlight that. We're going to justify each step. So that means that we're going to explain with each step what we're doing. So we have 7 plus g plus 5. I'm going to go in and I'm going to rearrange this and switch g and 7. So that's the commutative property of addition. Now that allows me to put my 7 and my 5 together. G plus 7 plus 5. Well, I changed the order. I changed where my parentheses were. That is the associative property of addition. If you misspell anything, that's okay. It comes with practice. And even with that, I was misspelling. So then when I simplify that, that is g plus 12. That step is just simplify. So that was number 4. I'm going to show my work for number 5 to the right. I have m times 11, that quantity, times m. So what I would like to do here is change the order of my variables. Change the order of my variable in number 11. So 11 times m, that quantity, times m. So this is the commutative property of multiplication. Very similar to the previous problem, number 4. However, the previous problem was adding, this one is multiplying. The next step, I'm going to change it to where my parentheses are going to go around my variables. So that's the associative property of multiplication. Which that leaves me with 11m squared. That step was just to simplify. Got it? Well, let's try letter E. We have 4 times 3c times 2. Well, I'm going to rearrange this and make this 4 times 4 times quantity, 2 times 3c. To justify my step, that is the commutative property of multiplication. Now I'm going to multiply my 4 times 2. That becomes the associative property of multiplication. Oop, not sure what happened there. Bear with me. Associative property of multiplication. So the quantity 4 times 2 times 3c. So I'm going to simplify. 4 times 2 is 8 times 3c. I need to keep these separate because there's an 8 and there's a 3c. Um, I'm sorry, not keep them separate. I have to multiply 8 times 3c. 8 times 3c is going to be 24c. So to get from 8 times 3c, that justification is to simplify. So your final answer is 24c.